All right, testing. We have sound. Uh, oh, is the filter right? Wait. Oh, I guess I cannot. Wait, back over filters. Yes, this is working well. Okay, I think we're ready. Okay, let me get settled up. All right, 3, 2, 1. Hello, how is everyone doing? Woohoo! Welcome back to Parametric Camp in its new edition of 2022. I'm super happy to be here. Do you realize Parametric Camp is about to be 2 years old? I can't believe I've been doing this for 2 years consecutively. I have a really hard time committing to long-term projects. I'm actually very happy that that I'm still doing this, that I'm excited about doing this, that I have people in the community that are excited about this, like our Plato, Nicolas. How was was your arm, Nicolas? Was it that it was your arm, right? How is it going? Arasto, happy 2022. Chandra, how are you doing? Thebas. Not sure how to pronounce that. Welcome back. Alexander, how are you doing? I am very excited to be here. I'm also a little high. I took perhaps too much coffee this morning. I'm still I'm still in the process of in taking some of it. And as you can see, I've also been neglecting a little bit my beard, which is not great because if we record some video today, whoever watches older videos in a more shaved state, now boom, this guy is gonna have all this beard for the next video. I need to start thinking about those things when recording series. All right. Okay, so what do we got today? Well, first of all things, let's be proper about things. So, hi, for those of you who are new to the channel, my name is Jose Luis. I run this thing called Parametric Camp, where we do live streams on computational design and on many different aspects. And record tutorials live, and then we trim them, we edit them, and we post them as more sleek, elegant, clean, to the point videos without all the jibby jabber and all the Jose Luis trying things out and things not working, etc., etc. So I'm very happy to be here. I like doing this together with the community. I actually love getting feedback as I am recording things. And yes, so we do this roughly every week. We've had a break during December because I was very busy with school and I also took some vacation. I was actually in the neighborhood of where Nicolas lives. He gave me some tips for some of his, I don't know, well, I won't get into the details of that anyway, but I had a lot of fun. I had a very relaxing break and I'm ready and full of energy to crack down 2022 and record a lot of goodness. If you want to know more about what we do, we have social media. We're particularly active on Instagram. You can follow us there and we post when we go live. If you want something a bit more consistent, we have a Google Calendar where we post when we go live. You can see a link to that calendar in the description of this live stream. And also, if you want to join the conversation that we have the community and ask questions and post your work, etc., you're more than welcome to join our Discord server. There is a link also to the Discord server on the description of this video. All right, so that's the boilerplate. So what are we doing today? What are we doing in 2022? So what can you expect from the channel? Because it's kind of that time of the year where we make New Year resolutions. I still haven't finished my personal New Year resolutions. Man, it's super.
it's perfect. I can see it here on my set memory. Wait, just yeah, wait for a second.
How about now? How about now? Hello? Let me put some batteries on the old. Let me put some batteries. Okay, so I switched from the lapel. I switched to the microphone, the ambient microphone. But let me check if I put some batteries. I really don't want to miss that. I really like that mic. Wonder what's going on there. Okay. How's everyone doing, by the way? How was your 2021? What are your New Year resolutions? You can still hear me, right? Yes. Feel free to post some of that on the chat right now. What do you want to learn? What do you want to learn this year? Do you want to learn C Sharp? Do you want to learn JavaScript? JavaScript is awesome. Do you want to learn that programming language that we don't really talk about much in this channel? Is that what you want to do in 2022? Really? Is that what you want to do with your life? Seriously? Okay, let me try switching microphones again. Because the thing is, this microphone that I have here was giving me a lot of trouble, a lot of problems recently. That's why we switched. Okay, this one is still okay. All right. Hello, 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 hello. Yes. Okay. Okay, and I'm going to switch microphones again. See if something. Okay, let me switch.
It sounds bad, right? It sounds bad. Yeah, no.
All right, so I guess we will do this microphone then. That's this microphone here. I really, really hope this is just some software stuff. And DJing, I can hear right now, Victor. I can't hear what's going on with the audio. So when I check the recording, I'll let you know if it's something that we can redo as a DJ filter or something. I'm using two microphones. I'm using an Audio Technica. You can see it here. That Nono gave me for my birthday, actually. Thank you very much, Nono, if you're here, and if you're not. And as a backup, I have this wireless set of this. I've been using this for 2 years. Actually, really, really good. The only thing that I don't like is that it uses a lot of batteries, which is not great for the environment and all that stuff. But if this thing breaks, I would be extremely, extremely sad because I really like them. But maybe it's a good thing. Maybe 2022 is a year to toss those things away and get a better wireless, etc., etc. Anyway, so I think we had good audio. The problem with this is that I don't know what the problem is with it, but sometimes it just like stops working for 1 or 2 seconds and it just mutes me. And it's just not great. Well, let's go back to business. So, what was it? New Year resolutions. So I still haven't finished my personal New Year resolutions, but one of them was to record 50 tutorials, 50 live streams last year in 2021. Unfortunately, we only recorded 42. So I missed it by 8. I guess we could have done like an intensive week or something, but I don't know. I guess I got busy. I have a job, all those things. So I think I'm going to set myself as the New Year resolution again this year to try and get and record 50 tutorials at least once a week, every every once a week, to stream once a week. So that would be amazing if I manage to do that. Now, in terms of content, what you can expect from Parametric Cam in 2022 is that we are going to finish the list that we've been working on for the past couple months or 3 months, the advanced development in Grasshopper. So that's what we're going to do today. We're going to no, Victor, it doesn't carry over. No, 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 no. Because if it carries over, then I'm definitely not gonna finish it. So, achievable goals. Okay, give me a break here. So, uh, so what were we? What I was saying? What I was saying? Yes. So we're gonna wrap up the advanced development in Grasshopper. Then I may do a couple of smaller things that I have in mind. I wanna try out the Grasshopper player. I think it's kind of cool. I also want to teach you how to make a small Grasshopper plugin, and like create your own commands in Rhino. That could be really cool as well. I may actually introduce those topics as part of the advanced development in Grasshopper list. So that's one thing. And extremely interested in making a full playlist on Git. So Git, GitHub, version control, how to do that for Grasshopper files, for general code files, whatever that is. So that's one thing. That's probably going to be the beginning of 2022. Also, I have an announcement. Yes. So I'm also this semester, I am teaching a new class here at the Graduate School of Design. I'm teaching a new class called Artifacts as Media, Signals, Data, Information, and Technology. It's a very fancy name, but basically it's a class where I want to focus on computational representations of media, so images, video, recursive algorithms, graphs, etc., etc., and then how to represent them computationally, how to generate them computationally, how to manipulate them computationally, and how to find hybrids in how to. It's an experimental class. I'm still trying to figure out a little bit the ethos of the class, but it's basically an intermediate, advanced introduction to computational design, if you will, and it's part of a series that I just started at the GSD where whoever is interested in computational design can start by taking Introduction to Computational Design, which many of you are familiar as a course. Then they can continue the next semester taking this class, Artifacts as Media, and then can further move on the third semester to take an active design, which is more of focusing on human-machine interaction. I think it's a nice thing because it's like a three-course intro, intermediate, and then advanced topics on computational design. And so I'm actually quite excited about being able to do this. I'm doing this for the first time this semester. This is the first time I'm going to teach this class. So I'm putting together a lot of content on what, I don't know, like image manipulation and recursive algorithms and etc. etc. 3D geometry from scratch, like from the render and everything. So it's kind of I'm kind of excited about this. So what I want to say with this is that first of all, because I'm teaching on Wednesdays, then we're going to move during this semester. We're going to move streams back to Fridays as it used to be. So you can expect live streams to be on Fridays. That's one thing. The other thing that you can expect is that maybe I interrupt at certain points. I interrupt the recordings that we're doing for certain series, like advanced development in Grasshopper, etc., just to record material for this class, so that I can use it as support material for my students. So maybe you show up one day in the live stream and then we're writing something, some image manipulation algorithm with kernels in JavaScript. I'm going to be using mostly JavaScript for this JS, 3JS, D3, like all the nice, cool front end JavaScript goodness. So yeah, so you can expect some of that. Arasto, yes, Remo Sharp, we need that very soon because Remo Sharp is happening next week. Like I was looking at the schedule of videos that I want to record, and it's really happening next week. So we need to coordinate on how to make this happen. Okay, during this week. Can we expect anything from Dynamo or Revit this year? Well, definitely not Revit. I don't think I'm going to be doing any Revit anytime soon, just because I find Revit a tool that is not that computational. I mean, it's like it's like an interface, drag and click. You create models, you add information. It's not so computational, perhaps. And at the same time, Dynamo is great to introduce computation in Revit, but Dynamo is very similar to Grasshopper. So if you know Grasshopper, you pretty much know Dynamo in a way. And I am very unfamiliar with the specificities of using Dynamo in Revit. So I would need to do a lot of research on that, and I'm much more interested in other topics for the time being. So I don't think you can expect Dynamo or Revit this year. No. Does the source just Git? Yes, we're doing just Git. Is it free to audit the class? Well, this class is not going to be online for the time being, so remote auditing, it's technically not a possibility so far. I'm sorry. And does the course code indicate anything GSD versus SCI? Not really. All the courses at the GSD, all the ones that are, let's say, more technical, they have the prefix SCI. I just chose to change that for GSD when I market the other class, the Introduction to Computational Design. But technically speaking, the real code is SCI and this number. So the actual Intro to Computational Design technically is called SCI 6338. But it's more of like a marketing thing, if you will. Upload or no, not C#. You were muted for 1 or 2 seconds. Exactly. That's the problem with this microphone, that it just mutes randomly. Rhino inside Revit. I'm not opposed to that, actually. We could do some of that. Rhino inside in general is something I wanted to give it a try. Arasto, don't you actually hate Revit? I do not hate Revit. I think Revit is a great tool for production, for automating a lot of the processes, the prosaic processes that go into making architecture, if you will. I don't think it's a design tool. I think for thinking architecture and for doing iterations, etc., it's not great because it's not very flexible. It's not very fluid. Like it's very rigid. Like it needs too much information at the earlier stages of design. One of my PhD students is actually working on exactly that, how to link BIM tools with early design stages and make the process a bit more fluid. I think Revit is great for that, but it's not for design. And I'm much more interested in design myself than in production. And also computationally, it's not very rich. It doesn't have like a scripting language. It doesn't have a lot of the computational things that I like. That is handled by Dynamo. And as I said, like I don't really have a lot of experience connecting Dynamo with Revit myself, so I may not be the best person. There's this YouTube channel, the BIM Girl, who has done a lot of work on Revit and BIM. So you may want to check that out, Revit, BIM, and Dynamo. She's got a lot of tutorials on that. So you may want to check that out. More about algorithmic thinking. Absolutely. I mean, every tutorial that we record is a representation of algorithmic thinking in a way, in a way. That perfectly timed mute. I don't understand what that mean by that, Victor, but you're probably complaining about the microphone, right? Rhino inside delegates in C# in Grasshopper. We could do a small thing on delegates. Why not? For events and that kind of stuff, right? We could do that. We could record a small video. We could add that to the C# playlist. And then we can add an example of how to use things that need delegates inside of Grasshopper, for example. That could be something interesting to do, Joe. Why not? Computational DJing. That would be really cool, huh? That would actually be quite cool, I think. Any other topics? Any other things that you would like? In Parametric Camp in 2022, this is probably the time for requests. Thank you, Shuruk. I appreciate that. All right. Well, the request pool is open, so you're welcome to put things here on the chat or on Discord. We actually have a topic suggestion channel on our Discord, and that's where I pick up most of the recommendations that I then end up introducing. So if you are interested, you're more than welcome to join the Discord server and to post your recommendations. Also say hi in the introductions channel. Say who you are, where you're coming from. I love getting to learn about people. So yeah. C# projects like the Umbracle. So you want to see more larger projects built in C# from scratch. Is that what you mean, Richard? I would actually want to do more of that. So if you suggest nice projects that we could mimic that we could model first in regular parametric modeling and then using C#, I will be super fine with that. So Richard, if you want, how about you join our Discord, and in the topic suggestions you put like a list of buildings or structures or things from the real world that that could be interesting to mimic and to model. We've done so far the Holocaust Memorial Museum in Berlin. We've done the Umbracle Canopy in Valencia. What else have we done? We've actually not done that many. You're right. We could do more of that. Coding in machine learning and AI. That's a great topic. I would like to do more of that. And I may do more of that later this year because my enactive design one, the third class of that series, it's and we're going to be using a lot of machine learning there. So I may record some tutorials on that. But I'm actually quite happy with the content that Nono is recording on that front right now. So maybe you can take a look at that there. Making proper meshes. Jarudi, I actually do have a desire to do some mesh specific tutorials because I think it's really interesting. I think it's computationally very interesting as well. So the algorithms you have to write require algorithmic thinking. To Shuruk's point, and I think it's a really, really good knowledge to have because at the moment you move into other platforms that don't support NURBS, knowledge of mesh manipulation is extremely useful. So I'm actually, for example, really interested perhaps in doing some content on 3JS, recording some 3JS tutorials. So I wonder, and for that, like having mesh manipulation is actually quite interesting to do. So maybe we could do some of that. Okay, beautiful. So okay, so I guess we're ready to start then today. What are we doing today? Today we are continuing with the advanced development in Grasshopper. We're going to record a couple of shorter videos. One is going to be, the first one is going to be, I would like to explain the difference between and GHX, explain what is the difference and why some of them could be interesting and some of them, for which cases each one of them could be interesting. So that's one thing. And the other thing that I would like to teach you is going to be custom previews. So let's say we have a C# component, we're writing in it, we're coding, we have a plugin, whatever, and what we want is to actually write our own, we want to render our own geometry or like certain things on the screen aside from the actual geometry that the component may output. So yeah, I know this microphone is just not great. So I may need to download the drivers or something. I don't know what it is. I have to look at that. Anyway, the second video is going to be custom previews in Grasshopper components. So that's what we're going to do today. And before we start, I'm going to take a mini bio break. I'm going to be back in 30 seconds and then we're going to get started. All right. Thank you very much. And I'll see you in 30 seconds. Okay, we're back. All right. So, oh, by the way, what did you think about the Christmas tree? How cool was the Christmas tree, huh? I'm still excited. You know, it's still in my living room and we still turn it on. We still turn it on every afternoon, every evening before we go to bed, right? And we just hang out in the living room. It's kind of nice. It's very cozy. So first of all, I need to check if this position on the screen is what I want. I forget. Hey, Saeed, how are you doing? Let me check. I need to check if I need to check the previous videos and see which corner we were using for the recordings. And I was using the other one. I was using the left one. So I'm going to mute my phone before it starts. I'm going to mute my phone. Exactly. And I'm going to switch. Oh. There you go. I'm going to switch myself to this side. And okay. And we're going to do. All right. So first video, Grasshopper files, Grasshopper file format, Grasshopper versus Grasshopper H. So I'm going to just make a simple sketch which is going to be construct a point, for example. Construct a point, and then 3 sliders, for example. 3 sliders. We're going to call this X coordinate, Y coordinate, and Z coordinate. And then I'm going to plug a panel here, all right, and I'm going to group everything as create a point from coordinates. All right, so a super simple definition. So what I would like to do now is I would like to have a folder that I'm going to call, for example, pcamp. And then I'm going to save that here. Example. And then I'm going to fire an instance of this, and I'm going to drop it here, and then you can see that it's binary, so because it's zeros and ones, etc., it's just a mess. But then I'm basically going over in my head basically through what I want to say. I'm going to save this as a GH file, and then I have 2 files. Then I can open this, and then we can see like basically document header, and it's got a lot of stuff. Maybe we should make it simpler. Is this something we want to do? Let's make a simpler file and see if, because maybe it's okay. So I'm just going to drop I'm just going to drop a slider. Slider name. Okay, and then I'm going to save this as slider, and I'm going to save this also as the Grasshopper file. And I'm going to drop the slider Grasshopper here. Preview selected. So the document header. Okay, document header, definition properties. Objects. We have objects. We have a container attribute. It's a slider. And false, and then it has some properties. Maybe I should start with a simple slider. I should start with a simple slider. And then we can show the more complex example. Maybe we can do that. Okay. Alrighty. Okay, so I'm going to close this. I'm going to close example. I'm going to take example out of here. And I'm going to close everything. I'm going to close this one as well. All right. And I'm going to shut down everything here. And then this should be halfway. Okay. And how am I going to start? I'm going to start by okay, I'm going to start by explaining what the video is about. I'm going to show the example of this slider. I'm going to save it in Grasshopper, regular Grasshopper, then in XML. Then I'm going to open it and I'm going to show some of the properties. And then I will show the second example, the one that was a bit more complex. And the one that was a bit more complex. And the one that was a bit more complex. And then after that, what I'm going to do is I'm going to explain what are the advantages of one and the other. And then I'm going to show an example of, for example, what we can do for procedural manipulation. Okay, I think that's going to be the plan. All right, so let's do that. I'm actually going to open Notepad, and can I have... And is there word wrap here? Okay. Okay. All right, beautiful. Shall we get started? All right, let's do this. It's been a while. It's been a month or something since I've recorded a video. So let's do this. Okay. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in this series Advanced Development in Grasshopper. In this video, we're not going to code a lot actually, because what I would like to teach you is the difference between the two main file formats that Grasshopper can save to, and what are the advantages of one and the other, and when should we decide to use one versus the other. And what do I mean by this? So let's start with a very simple example. Let's say that I'm going to create a slider that goes from 0 to 10. And literally, that's the only thing I'm going to have in my Grasshopper definition, all right? I'm going to rename this as slider name, and I'm going to set the value to whatever, okay? That's it. That's just my entire definition. By default, if I were to say, I want to save this document in my computer, and I'm going to save it to some folder called Parametric Camp, for example, and I'm going to call this slider. You can see that by default, what Grasshopper offers me is to save this file as a Grasshopper binary, or with the extension GH. If I do that, which is the standard, is the default, is what you get if you don't specify anything, and then if I go to this folder, you can see that now I have a file here called slider.gh. If you don't see the GH, it's maybe because you have configured your system to hide extensions for known files. So I recommend that you view, you disable, what is it called? Hide extensions for known file types. It's always nice to see the extensions of the file, especially if you are in the hacker programming side of things in your life. Anyway, so you can see that this file is now Grasshopper GH. And what this means is that this file has been saved as a binary. What that means is that Grasshopper, when it saves definitions, the definitions are internally saved in this format that is called XML. XML is a structured file format where the data and the properties that are stored are basically saved in a hierarchical way. But because this has been saved as a binary, what Grasshopper does is that it takes that XML file and it compresses it with a particular algorithm, and then it turns it into optimized zeros and ones. What that means is that this file is very optimal as space saving, so it's much lighter on your memory-wise on your computer than the original XML file would be. But the problem with that is that if I were to try to now open this file on a regular text editor, for example, this one, I would basically get gibberish. I would get something that is not understandable. This is mostly Chinese characters for some reason, but I don't think that these Chinese characters actually mean anything. If I were to open this, for example, on a code editor like Visual Studio Code, you can see that the file, it tells me that it can't be opened because it's either binary or unsupported. So if I just open it anyway, you can see that I get these like weird characters that are basically unintelligible for a human. This is because, again, this original XML format has been compressed using compression algorithms so that it's a bunch of zeros and ones that save a lot of space, but cannot be read as characters in a text editor. All right? So what Grasshopper gives us as a possibility is to, instead of saving in this binary compressed optimized format, we can save the file in the original. Let me go to save document as. We can save the document in the original file format XML with the extension GHX. What that means is that this file, now I'm going to call it the same, slider.ghx, and you're going to see that in my computer, now I have two files, the Grasshopper file and the Grasshopper X file. You can see that this one is 4 times larger memory-wise, right? But the nice thing about this one is that if I now open any text editor and I drag this file in there, what you can see is that I can see actual human code. I can see letters, text, and I can kind of understand what's going on, more or less, all right? There's a lot of data here, but at least the data has been saved in a text format without optimization, without compression, etc., that can be read very easily by any text editor or by any script or any algorithm that you write that does text and string manipulation. All right. I've been using Notepad to represent any generic text editor, but I'm going to be using actually Visual Studio Code for this tutorial, because if I now drop the GHX file here, you can see that what I get is nicely color highlighted representation of this file, because since Visual Studio Code is a text editor, it understands that what I'm reading is an XML file that has a particular format, a particular set of standards, and is able to highlight with different colors the different things that are part of this file. Okay? Now, this is great because what this means is that the Grasshopper definition that we have here, which is just this one slider, actually has a sort of, it's not really exactly code, but it has a structured data representation that is parsable with strings and with any machine. What that means is, if we look closer here, we can see that it's an XML file. And an XML file, in a nutshell, you can Google this, but in a nutshell, it's basically a file that has pairs of tags. So for example, anything that is opens with an items needs to be closed with an item. Anything that is opens with a chunk needs to be closed with a closing chunk here, etc. Everything that opens with an ARGB gets closed with a closing RGB. This character here, the / means closing the tag. And then information is wrapped always between opening and closing tags. And where these tags are, whether if they are inside another group that opens and closes some other tag, is this hierarchical nested way of representing data. This is very useful because it's very easy to do machine parsing with this kind of information. For example, some things that we can learn about this file. There is an item that has the name archive version of Grasshopper, and we can see that this file was recorded with major version 0, minor version 2, and revision version 2. So that's 022 is the version of the archive that this file is using. The plugin version, I think this refers to the Grasshopper version, is 107. Okay? Then there's a header that specifies a bunch of things. So for example, the color of the preview, this is in format ARGB, so 100 opacity, and then or transparency, and then 15000 that is like a medium red, right? Whereas preview selected, it's an RGB color which is half transparent and has 0, 150, and 0. So that's like a middle green, all right? So we can see that when we open a file, the preview colors are actually part of the file. They're not part of your general Grasshopper configuration, which is kind of interesting as well. Properties of the file. Well, the projection where the file is looking right now in XY, the zoom level of the file as well, how many views it has, and this, which is arguably the most interesting part, the definition objects. So how many objects are part of our definition? And you can see, if I wrap the files, you can see that there's only one object, and that this object is of the type number slider. It has a bunch of attributes, description, the name, the nickname, and the nickname is the one that I wrote, slider name. And it has a bunch of attributes. So for example, where it is in the definition, so the X, Y, the width, and the height, and then another bunch of definitions, such as, for example, how many digits, how many decimal digits, what is the interval, the maximum value, the minimum value, and the actual value that the slider is set to. Okay? And last but not least, a thumbnail representation. So this is a string representation of an image with a particular encoding. So that is also, you can see that also Grasshopper files embed a tiny thumbnail inside of them. So I find this extremely interesting because if we can save Grasshopper files in their original uncompressed text format, then that gives us the possibility of doing a lot of really interesting things, such as, for example, using machine code, using computer programming to do parsing of these files and, for example, retrieve information about these files. So what we could do is we could write a script that goes through a folder of Grasshopper definitions, and it looks at every definition and it figures out how many components a definition has. We could do that with machine code. Or, for example, let's say we want to change the location of our components for some reason. So we could just look at the XY of all the components and maybe like move them around, like push them away, or like just compress everything into one single point. So we can do this kind of procedural manipulations. So, and actually, before I move on into describing pros and cons of each kind of format, let me actually show you an example of some kind of manipulation that we can do on Grasshopper XML files. So let me show you an example. Victor, yes, theoretically, if you had a good grasp of the format that Grasshopper uses and like all the parameters and all the properties and everything that a component needs to have, you could just write them from scratch. Yeah, you could just generate procedurally XML files that contain all this information without even owning a Rhino license. Yep, that is theoretically possible. Okay, what else? Something that else that you can do, Victor, for example, is let's say you want to write something in JavaScript in web that imports a Grasshopper definition, and maybe it doesn't do any geometry operation, but it gives you like a diagram. It gives you a diagram on JavaScript. So what you could do is you could parse this file, figure out all the components and their location, draw those on a JavaScript canvas, and also draw the cables that connect them because those are connected here, So that's also very doable. Okie dokie. So what was I going to do? Oh, yeah, I forgot to show another example that I wanted to do. Anyway, so Timothy, I am not sure how Lunchbox operates or what kind of operation you are referring to. Oh, I want to show how to convert between two formats. I want to show, yeah, I need to show a tool that is out there to convert between the four file formats. Okay. Let me, I need to find a couple sample files. Let me browse real quick. Sets. Curve analysis. All right. Okay. Yes. Okay. Okay, I'm going to bring here a I'm going to bring this here. I'm going to close this. I don't need this anymore. I copied them here. And then I'm going to open one of them. Here, I'm going to open, for example, okay. I can show that while I'm doing this. Okay. So, for instance, let me show you an example of this. So, this is the Grasshopper Sharp project. It's a project that I worked on and that I maintain with a set of open source community people that have helped me make this. It's basically trying to reproduce with C# scripting as many of the original vanilla components. I think it's a nice, fun project to do. But anyway, so and a link to this repo should be popping as a card here somewhere, and there will be a description to this, a link to this also in the description of this video. So if we go to source, what we can see is that basically we have a few folders where each folder represents one of the tabs that we have here in Grasshopper. So either vector, curve, surface, correct? And then if I go inside, for example, curve, you can see that we have one file per each one of the tabs that we have for the curves family. So analysis, division, primitive, whatever, etc., etc. And as you can see in this project, these files are saved in Grasshopper X format. I will get to why this is the case very soon. But for example, if we click here, what this means is that, well, this file is a little too big, but I can actually see it. And you can see that I can see on GitHub the actual code of this file, the XML representation. All right. So if I were to copy and paste all of those files here in the folder that I'm writing, that I'm working on, and for example, I can drop the curve analysis file here. You can see that if I zoom out, what this file is basically trying to do is reproduce all the curve analysis components using C# scripting. So for example, is the curve closed? So I double click here and I have code that does the exact same thing. We've talked about this project in other parts of this channel, so you're welcome to check it out and use it to learn some more C# techniques inside of Grasshopper. Anyway, but you can see that one of the things that we do in the project is that whenever one of the components is not fully well, implemented for some reason, certain parts are missing, or we couldn't reproduce the full functionality, that component is, that group is grouped with this kind of orange group, all right? And you can see that particularly in this file, there's a bunch of these, these orange groups, right? If I go to Visual Studio Code and I now open the curve analysis file, you can see that it's a very, very large file. It has like thousands of lines of code, like, 28,000 lines of code. And there's a lot of components all the way around here, and so actually breaking these definitions, these XML files down manually is actually it's not complicated, it's just tedious because there's so much stuff and so much information. For us humans, for a machine, this is extremely, extremely easy and fast to do. But one thing that we can do, for example, is that we can just Google, we can just try to find in the file the word group. And you can see that here we have a group of Grasshopper objects, which means that this XML here is the one, this whole thing here is the one that is representing the group in a definition. And you can see that it has a bunch of properties. For example, it has the GUIDs, or if you want, the signature of the components that this particular group is grouping, so that when we open the file, the group can just wrap all these components together. But something that it also has is the color. So you can see that the color here is an ARGB representation of that is an ARGB representation of the color that is used for the background of that group. Okay, so let's say that instead of going manually to each, let's say that for some reason we don't like this orange color, and that instead of going manually to each one of these and changing the color and blah blah blah, which is 255, 191, 145, did we find it? Oh yeah, we found actually one of the orange groups. That's great, right? So let's say that instead of doing this manually, going to each one of them, changing the color, etc., and then doing the same thing for all the orange components, we wanted to do this programmatically. Something that we could do is we could write a small script that goes through the text in this file and then finds this particular sequence, the ARGB color that we can change, that we want to change, and we can replace it with a different color. All right, that is actually very doable. So how are we going to do this? Well, just for the sake of making things easy, we are going to use, that programming language that starts with P, just because it's kind of easy. And because for those kind of like banal, trivial manipulation things, it's actually a pretty good programming language. So we're going to write a Python script to parse through the text in this file, and then trying to find a particular string sentence and replace that with another string. Okay. So how are we going to do that? I'm actually going to be copy pasting from an example that I found online from author Pippery and Shiram, all right, and which is a very simple Python script to replace a string of text in a particular text file, all right? So how are we going to do this? Well, I'm going to create a new file. First of all, I'm going to open a terminal here in the folder where my files are, all right? So you can see that I am on my desktop on the pcam folder, and then I'm going to create a new file by typing code, and for example, replace.py, all right? What this is going to do is that it's going to open my Visual Studio Code with this new file that I've created, and as soon as I save it, you can see that it shows up in my folder as replace.py, all right? And for example, I can say print hello there, all right? And then I save this file, and then I can run Python replace, and then I get a printout here in the console, all right? If you don't know Python, or if you don't, it's fine. You can look at some tutorials out there. The purpose here is to make just an example of how we can replace strings in a file, all right? So what I'm going to do is I'm going to copy and paste this text. I will probably have the link to this question somewhere as a card or in the description of this video, all right? And I'm just basically going to copy and paste all of this here, all right? What this file does is it imports a bunch of system modules to do manipulations with files. And then it asks the user, what text do you want to search? What do you want to replace it? And which one is the file? And then it does a simple manipulation where it opens the file, it goes line by line, and if it finds this text in the line, it replaces it with the text that we set. All right, I'm going to save this, okay? And what are we going to do? What we want to do is we want to find this color, the orangey color in the file, and we want to replace it with something different, for example. So I'm going to run Python replace, all right? And what is the text that I want to search for? I want to search for this orange color. And I'm actually going to use the full XML representation with the text, all right? That is the text that I want. And now, what do you want to replace it with? So I'm going to replace it with something similar that is going to be perhaps like greener. So I'm going to do full green channel, and I'm going to crack this down to 100, for example. So I just don't know what color that is, but let's say we knew this because we had an RGB swatch or whatever, okay? And then what is the file that I want to do replacing on? So the file is going to be curve analysis. So I'm going to go here, I'm going to copy the route. So the file is here, and then it's called curve underscore analysis dot GHX, okay? As I do that, then it's going to print out a lot of stuff on the console. But you can see that this file in my Visual Studio Code already updated to this new color, okay? What that means is that if I go to Grasshopper, Grasshopper doesn't have those changes because the Grasshopper is not reading the file continuously. But if I close this and then I drop this file again, we can see that now, ta-da! All the colors are now green. Whoa, how cool is this? I changed the color of these groups programmatically using a Python script. Okay, but you see the point. It's actually quite easy to do massive changes, procedural changes on a file just by doing simple string manipulation. You could say, well, Jose, like you weren't very clean because you basically just used the color string. So if there was any other object, like for example, a panel or like other groups, whatever that share the same color, you would have replaced it now, and you would be right. I was like very, very specific because in this case, I knew that it's just the groups that have the orange color. But you can get more sophisticated. You can write better scripts that actually look at the XML. You can actually use libraries in Python that read XML formats and parse XML format and then do smarter manipulations based on that. But we're not going to get into that because that's not the point of this tutorial. All right. Okay. So what's next? What I want to say is now I want to get into advantages and disadvantages of this format. So that's one thing. And the other one thing I want to do is I want to okay, add card to, then add card to here, and okay, and then sorry, I'm just fixing a couple things on my end. All right, and then I want to do is Grasshopper UXH to GX converter. All right. Okay. I may want to show an example of it. So for example, Bitbucket download pages. Okay. I'm going to save this. I'm going to save it at pcamp. And then here, I'm going to say all right, H. If extension. How to drop the file anywhere on your hard disk and also place your own copy of the in the same folder as the executive, and then it should simply work. These other files are available in here. I think I've used this before. I wonder. So, programs, Rhino. Where is Rhino? Neil. All right, let me try to find Rhino because we need Neil. Rhino installer. Nope, I don't want the installer. I guess I want the user. ELS, McNeil, application data, local, McNeil, Rhino. So McNeil, Rhino, 7, autosave, no. Oh boy. Okay, so let's find the files. So special folder components. So application data, it's in roaming. Okay. It's in roaming. Is it in roaming? Rhino 7. Where the hell is? Okay. Rhino. Open file location. Windows start menu. And then where is this? Program files. Rhino 7. Are you kidding me? Program files. Is that what it was? Oh God. Okay. So, all right. The Grasshopper. Oh no, but I need Grasshopper, not Rhino, because it's Grasshopper IO that is needed. Okay. So where were we? Components folder. And this was for roaming. Grasshopper 6 libraries. Autosave. Libraries. Oh, wait. So maybe it's in system. Plugins. Grasshopper here. There you go. I'm going to rename this. And then, nope. Not that one. Oh boy. I'm really clumsy today, huh? What is going on here? Should I use command prompt? Is that what's happening here? File not found exception. Could not load file assembly console app. I have never had this problem. Oh, what the hell? Oh. If you're installing compile X files, you can quickly get started. Drop the X file anywhere on your hard disk. Then, if needed be, Downloads, compile, download repo. Oh boy. Oh boy. What is this? Okay, extract here. Console app. And I'm going to, it's opening Visual Studio. I may need to compile this myself. I don't know what's going on here. Okay. The program. And then using console app. And it was just console app. Okay, well. I guess, can I build this solution? Okay, so it got built. So now it's under, so where is it? Run interactive mode. I guess it's here. So let's see. I don't know. Let's see. So Grasshopper. Oops, nope. Here. What are we? So Grasshopper 2. Okay, I think I'm wasting a much more time. And then, so I may, instead of showing an example, I'm just going to point to the repo. Because this is not taking me anywhere. I've actually used this in the past and it was working fine. I really don't know what's going on today. Anyway, so I'm going to do this and that and take this out of the way. Okay. Hey, no, how are you doing, sir? Okay. Alrighty. So what else do we have? Okay. Okay. Okay, so, all right, so let's go back. So the question now would be, when do we use one format or the other, right? So I think it's actually quite easy. So first of all, if you are just developing stuff, simple Grasshopper user, you're just saving your files and you really don't care about much, then definitely stick to the standard format, the binary one, just because it's going to save you a lot of space in memory. It's like somewhere between 4 times and 10 times the footprint of the file. It's actually kind of ridiculous, the compression of just simple plain text. So, however, you may want to consider saving your files in the XML format if, for example, you are expecting to do some kind of mass analysis of files. So you have a large collection of Grasshopper scripts and you want to write a script that changes your author name in all of them, or you want to see what is the average amount of components that you use for each one of your definitions, or you want to write some machine learning algorithm that learns from the representation, whatever that is. If you want to do parsing with other means of large sets of Grasshopper files, then definitely having those files in the XML format is actually quite helpful. Similarly, if you are writing Grasshopper definitions and you're versioning those definitions in some kind of version control system like Git or like Subversion, then I would definitely recommend that you use the XML file format because binary files cannot be versioned in Git, for example. If you have a binary file that gets saves and zeros and ones, and then you change something in the file and save it again, basically the full file is saved with the new commit. What that means is that every time you commit something, you're basically forgetting about the old file and you're saving all the information of the new file. And that over time will accumulate into a Git project that is extremely large. On top of that, it kind of defeats the purpose because the whole purpose of versioning is to be able to see the differences between the version that you had before and what changed in the new version. And because when you save a file as a binary, basically all the zeros and ones kind of change based on the compression, then it is impossible to do that with binary files. However, if you save your files in a format that is easy to read as text, then version control systems can see the previous version, can compare it with the new one, and then they can tell you the difference. So for example, that is the reason why in the Grasshopper Sharp project, we had all the source files, we had them saved as Grasshopper XML files, so that when I open them, I can see the raw file, or I can go and see, let me see the commits list. Oh, I can see that the last file that was changed was the freeform surface one. And you can see that there was a lot of changes. There were a lot of changes, like 3,000 changes. So I'm actually loading the changes. And you can see that Git is able to tell me that, well, the position of this component changed, the zoom level of the file also changed. Like for this particular item, we removed this one and we added 3 more to the group, etc., etc. So I can kind of see the differences between the files, but at the same time, the way this is saved in the Git project is much more optimal. All right. So if you are saving if you have a Grasshopper definition that you're versioning, then I really recommend you use the Grasshopper XML file. Okay. However, not unless this is a GitHub problem or a versioning problem, if you want to do massive changes, if you have a large collection of Grasshopper files and you want to make massive changes or like procedural changes, and you just so happen to have all those files in regular binary format, that is fine, because it turns out that because the binary file is basically just a compressed version of the XML file, going from one or the other is actually quite easy to do. It's just a matter of compressing or decompressing the file. And there's actually projects out there, so as like, for example, this project by Ruffle, which gives us a command line tool that allows us to programmatically or with code change large amounts of files from Grasshopper to Grasshopper XML or vice versa. Okay, so I will post a link to this project as part of these cards, as a card here on the video or in the description of this video as well. All right. And yeah, and that's pretty much it. I find peeping through the XML actually quite interesting, and sometimes it's also very helpful because sometimes when we do some kind of manipulations of files, we actually need to know what is the GUID of some components or the global unique identifier of that component, and we can actually very easily see those as part of this file. So taking a look at the file is always kind of interesting as well. All right, beautiful. With this is as much as I wanted to say about this topic, and we are ready to move on to the next video in this series. However, in the meantime, if you found this useful, if you liked the content, then maybe consider liking this video, or subscribing to the channel, and all those things YouTubers do these days. Thank you very much, and see you on the next video. Victor, that I'm not sure about that. I think GitHub Actions are more about compiling a project, running tests on the project, but they work with whatever you push as part of the commit. So if you push something that is compressed, that's how it stays in the project. So it doesn't really, it kind of defeats the purpose. It's not, I basically wouldn't do that. I don't think so. All right, beautiful. That was that project. Now we're going to do custom previews in the next video. I'm going to take a small break. I'll be right back. Give me 1 minute. I'll be right back. All right. Yeah. I can't believe we did Python. Ew. How are we starting 2022, huh? We're living crazy times, folks. Crazy times. If Parametric can start the year with Python scripting, all right. Okie dokie. So, so this is gonna go. We don't need any of these anymore. Parametric camp. Oh, these are the. We probably want to keep these files. I guess, yeah. We're gonna keep these files. Anyway, what are we doing next? We're going to do custom displays. I did write a quick example. Let me review this example. So I'm gonna call this anchor, and I'm going to call this a vector, and this is going to be a point, right? And then we're going to set this one point here. Yeah, right. You guys are laughing, huh? And you find it funny. I don't know how I feel about this, you know? Okay, whatever. Okay, and then whoa, those came out perfectly, and wow, that is some fine OCD level there, huh? Awesome. Okay, so I got the vector, and then I'm going to. So the whole point was. Oh yeah, I have to type this, folks. So that's going to be a point, and that's going to be a vector 3D, and the whole gist here is I'm preparing the file before I record the tutorial. All right, and then we need to have this here, okay, and then we we have a line. Oh, I see. Oh, we don't really need to. Get display line, bounding box. And then we need to do this. I mean, at this point, oh, I see. So we could phrase this as, we don't really need this. And we could phrase this as we're just going to draw vectors, you know, of sorts. Okay, well, we don't need this. Plus length. Okay, and if I change this, okay, that works. And okay, I think this could work. So we can probably start with something like this, where we got nothing here, and we got nothing here. Okay. I'm gonna call this custom display. And we're going to call this custom rendering. Custom rendering. Okie dokie. Okay, how are we going to start? We can create a line from a point and a vector, right? Do we have such a thing? Oh, we don't. Starting point, direction, and the length. Okay. Okay, I'm going to turn that off. Okay. All right, let's do this. Hello, and starting over again. Howdy! This is Jose Luis here at Parametric Camp, and welcome to another video in this series, Advanced Development in Grasshopper. In this video, I would like to teach you how to create custom previews in your Grasshopper components. And what do I mean by custom previews? So for example, let's say we have the problem of a point somewhere in Rhino in 3D space, all right? And then we have a vector with whatever coordinates, let's say 10, 10, and 10, or whatever number, right? And then what we want to do is we want to visualize a vector that is sticking out from this point somewhere in the direction of that vector, all right? We know by default that Grasshopper is not going to give us a visualization of this vector because vectors are entities that have direction and magnitude, but they don't have a location in three-dimensional space. So that's why we have to artificially give them a fake location, if you will, so that we can visualize them somewhere in 3D space, okay? There are several ways to do that. So for example, let's say we wanted to kind of mimic that idea. So what we could do is we could just use this component, the component line from a starting point, a direction, and a longitude, all right? And if I turn this visualization on, you can see that I can kind of see this line going in the direction of the vector, all right? However, this has a couple problems. One of them is that it doesn't really look like an arrow, like a vector, right? So I don't really know. If I couldn't see this point, I wouldn't really know whether if it's pointing that way or the other way. And the other thing is that we can see this line because this is Grasshopper default visualization of the particular geometry that this one component outputs, all right? Now, this may or may not be useful for us, but maybe if we are like a bit more advanced, we actually may want to do something closer to this other tool that Grasshopper gives us, which is vector display. You can see the vector display is this tiny component that doesn't have any output, but it takes one anchor point and the vector, and it gives us this kind of arrow looking sort of thing that we can turn on and off, right? And that is now basically pure preview, okay? So we're going to want to do something similar to this. So what I would like to do is I would like to write a C# script component that is going to take an anchor, is going to take a vector, and the anchor is going to be of the type, you can see it is flowing on my other screen. It's a type vector 3D and point 3D, and the vector is of the type vector 3D. All right, I'm going to plug these two in here, and then I'm going to double click, and you can see I have my anchor, my vector, whatever. And what I would like to do with this component is something similar to what the other component was doing. Just no geometry manipulation, no outputs. I'm actually going to remove this output, and we could also even remove out. I'm not going to do that because I like having the console, but we could remove out to just basically have nothing, all right? And what I would look to do now is use this code to just purely display on the screen some custom preview like that arrow, all right? How could I do this? Well, actually, thankfully, Grasshopper gives us custom methods and custom tools that we can override in order to bypass the standard preview that is by default rendered by Grasshopper to any geometry that is output by the component. And instead of that, we can draw our own geometries, if you will, for the purpose of previews. What does that look like? Okay, let me show you an example. First of all, the way we access those special methods to do custom rendering of custom previews, is by clicking on this icon that we have here, that is the preview overrides. When we do that, what we're basically adding to our code is a bunch of functions. So a property, in this case, clipping box, or two functions, draw viewport meshes or draw viewport wires, all right, that override the native functions that are embedded in this component. And whatever code we write here will override the default code. So Draw viewport meshes is a function that we would use if we wanted to draw geometry that has a mesh representation. So a surface, a B-rep, etc. Something like that. All right. Since we're only going to draw an arrow, I'm actually not going to use this one here at all. I'm going to leave it here for the purpose of examples, but I'm not going to use it at all. The other one that I'm going to use is the draw viewport wires. Wires are not the wires that connect Grasshopper components, but wires are basically geometry that can be drawn as a thin line in Grasshopper, okay? Or in the Rhino viewport. So this is the one that I'm going to be using. And you can see that by default, this method takes this argument called the preview arguments. This argument is actually really useful because it gives us access to the drawing methods that we need to throw geometry into the Rhino viewport. Okay, so if we actually go to args dot, we can see that we have a bunch of things that we can access. So for example, we can access the display, the documents, some materials, the viewport, etc. So what I'm going to do is on the display, I'm going to press dot, and you can see that now I do have a lot of methods. Can you see all this draw stuff? Draw 2D line, 3D text, annotation, arc, arrow, bitmap, box, circles, whatever. There's a lot of stuff that I can do. So let me, for example, let me just draw a cylinder, like a simple cylinder. Is there a sphere? Maybe we can make this a bit simple. Is there a sphere? Yes. Draw a sphere, and then let's see which parameters it needs. It needs a sphere, and it needs a color. So I'm going to create a new sphere that is going to be centered at 0, 0, 0, and the radius, so a sphere that is going to be centered in a point is going to be centered in a point, so new point 3D. I'm just doing a random example, okay? And with a radius of 2 units, for example. And then going back to the original draw sphere function, you can see that it also needs a color. So for example, I'm going to do system, drawing, color, and I'm going to choose from the list. It's unfortunate that this thing is so low on the screen, but I'm going to choose, for example, coral. I like scuba diving a lot, and I like orange as a color. So if I'm going to run this code, and you can see that all of a sudden, artificially, this component is giving us a preview of this NURBS sphere that is centered on the center. And depending on which shading we will use, actually we're not getting a different shading. Oh, because we're drawing this on the wired preview. Sorry, I forgot about that, right? So we can use this sphere as a custom preview, all right? And if I turn this off, you can see that the preview is gone, all right? So what that means is that we can use that method to override and create our custom visualizations. So for example, let's say that we want to use this anchor and this vector to create an arrow that is sticking out from this point in this direction. All right. So what I'm going to do is I'm going to do args dot display, and then I'm going to draw an arrow. What is that here? Draw an arrow. All right. How does that work? Well, it has two overrides. One is takes a line and a color. The other one takes line, color, and the screen size and the relative size. So we're going to just use this one. However, we actually need a line object in order to draw this arrow. We don't need a vector, which is kind of weird, okay? But we need a line, all right? So where do we have a line that represents this anchor and this vector? Well, what we can do is we can create a line that we can give to the draw viewport wires to get rendered. So how are we going to do that? We're going to do that here. We're going to say, I'm going to create a line called arrow. And that's not a great name, but whatever. And that line is going to be equal to a new line that goes from anchor. Do we have? Yes, anchor and in the direction of vector. All right. Okay, cool. So now we have a line that represents the arrow that we want to use. to draw. But the problem is that if you remember the rules of scoping, because we declare this variable here inside of the run script function, this variable is actually going to disappear and not going to be available here. So for example, if I say system drawing color coral, all right, and if I now try to render this, I get an error, and the error is going to be, this is why you never should remove your output panel. The name arrow doesn't exist in the current context. The variable was defined here, and therefore when we finish the execution of run script, this variable disappears. So how can we access the arrow value from the draw viewport wires function? Well, if you remember from our previous videos in this series, we discussed how when we were doing animations, etc., we discussed how in order to create persistent data that is accessible to all the functions and is part of the global scope of a run of a script component, what we need to do is we need to define variables outside of the function in this area here, which is the global scope, or if you will, is the base scope of the full class that a Grasshopper script component is. So what I can do is I'm going to define the variable here, and then here, every time the script executes, I'm going to update its value with whatever new things are coming in. If I do this, because this is now available in the global scope, this variable is available here. So if I run that, you can see that now I have this orange custom pre-visualization of the vector that I want to visualize. And then if I change things around, this is going to update as expected. And if I turn the visualization off, it turns on and off. The problem is that it now doesn't do the thing where it goes from green to red when I click the component, because since I'm overriding my own function, my own pre-visualization, it overrides all those goodies that come from Grasshopper. Okay, so some pros and cons. I believe there should be ways to actually detect when a component is clicked and change the color, but I don't know how to do that off the top of my head. Maybe that is homework for you, okay, or for some future video. But some other things that are interesting are, for example, the fact that we have the arrow, but there's also other stuff that we could use as pre-visualization. So for example, this component also gives me the length, but the length is kind of difficult to perceive from how could we render the length in this arrow? So something that we can do, for example, is with custom previews, we can actually display text on the screen. So something that I could do is I can say, for example, let me calculate the length of the vector by saying arrow, can you just give me the length of this object? All right. I'm going to move this a bit farther up so that it's easier to see, right? And then what I would like to do is I would like to display that number on the screen, okay? So for example, how can I do that? I can go to args.display, and then you can see that I have draw to the text. This looks promising, all right? So let's see what this needs. First of all, it needs the text. So I'm just going to throw in lang, and I'm going to just forcefully convert it to a string. Lost. I'm going to do length, then I'm going to do system.drawing.color, and I'm going to do black for this one. All right. And then what else am I going to do? It needs the coordinates on the screen as a point to D. What is that? Let me define this beforehand. So I'm going to define point to D, coordinates on the screen, location is going to be a new point to the object, which is going to be, for example, pixel, I don't know, 25 and 25. All right, so the top left corner. And then, so I'm going to use location, and then middle justified. What is that? Whether if it's center or not. So I'm just going to do false. So it's going to be justified to the left. let's see how this works. So I'm going to click on this, and then I do have an error. So cannot convert from double to string. Okay, so what I was doing before is actually what needs to happen. So this I'm going to convert here, and then I'm just going to add these other parameters here so that they're easier to read. Okay, so length to string, system, location, etc., etc. And now you can see that the rendering is the arrow, but it's also this tiny text here. Okay, so I have this and have this, and there's probably ways that I can customize the typeface, and I can customize the size, etc., etc. Right? Or for example, let's say that instead of the top left corner, I want the bottom left corner. All right. How could I do that? Well, what you could do is you could say, well, I'm just going to give this a really large number, like 500, right? So I'm going to try that. But that's kind of like halfway through. Okay, well, then I can do 800. But now it's like way too much. Okay, I can eyeball this to 700. All right. And then it's probably somewhere there. But as you probably can imagine, that is not a great method, because now if someone resizes the screen, the thing doesn't stay there, okay, in the rendering. So how can we do this more programmatically? Well, we can, if you remember from the previous videos, we can actually access information from the screen using the Rhino API. So for example, we can read the size of the screen. We can read it by saying, let me access the Rhino document property of this component. And then here, I'm going to access for the views, get the active view, the one that is currently being displayed. And from that, let's go to the bounds object, one that has the 2 dimensions. And then let's see what is the height of that active view. All right. And then whatever the number is, I'm going to subtract 25 from that. All right. Let me open this up. And if I do that, you can see that the number is now nicely displayed there. And if I resize the screen, because this function gets called over and over, you can see that this value gets its permanent here on this tiny corner right here, okay? And I could even be a bit nicer and just say vector, and I could just say the text is going to be vector length, and then close curlies, etc., etc. And then now you can see that I have an even longer display, like a more verbose one. Okay, beautiful. Now you may wonder, Jose, but how the hell did you know that you could get the height from bounds, active views, whatever, blah, blah? Well, that I mean, I wasn't born knowing all of this. This is by experience, a lot of Googling, a lot of Grasshopper forums, etc., checking the documentation and taking a look, just simply spending some time looking at, if you just type Rhino document, and then if you type views and active view, and then you just sit down and be like, okay, what do I have? A handle, a floating, the display pipeline, the document, what are all this stuff, the client rectangle, active viewport ID. So just sitting down sometimes and looking at what the autocomplete gives you and what that might mean is also very helpful sometimes, just tinkering, okay? If you don't know where to start, the documentation is a good resource. If you don't know how to do something, just Googling it and going to the Grasshopper developer forums is always a very good thing to do as well. All those things can help you a lot, all right? And I think this is where I wanted to leave it for this video. I believe so. This method that I just showed is very, very specific to C# script components inside of Grasshopper. As soon as we move on to the next sections, where I will teach you actual development of Grasshopper plugins from scratch, these methods will vary a little bit, but you're welcome to keep checking out this series and then learn how to do this with raw from scratch Grasshopper plugins. Okay, it's very similar actually. You will see. Okay. Thank you very much. If you like this video, maybe consider hitting the thumbs up, subscribing to the channel, and in the meantime, I will see you in the next video on this series. Thanks a lot. Bye bye. Beautiful. Beautiful. We're getting robots? I just killed a robot, I think. Are we getting robots now in the channel? Oh boy. Yeah, there was one, and I just killed one, and there was just another one that showed up earlier. Oh boy. Anyway, I think that's it for today. Arasto, if you're still around in the channel, the very next video we're recording is Remo Sharp. So we need to touch base because I need a sample file that I can use. And I would like links to your tutorials because they're going to happen very soon. Okay, so let's get that done. I'm going to close this here. Okay. All right, yes. So let's connect on Discord and coordinate this because Friday next week we're doing Remo Sharp. All right. And any questions, comments, things you want to discuss, anything? I'm open to a little bit of social before I move on. Victor wants to do Compass tutorials. But we have a problem with that, Victor. You know what the problem is, right? I actually think Compass is pretty awesome. And I'm actually quite excited about doing Compass. But if we do Compass, we're gonna have to do Python first. So I don't know. Maybe this is the year where we record the Python series, and then we do Python for Grasshopper and blah blah blah. We'll see. I don't know. Maybe I get COVID and my brain just reshapes, and now I love Python and that kind of stuff. You know, who knows? Maybe pcamp Python, pcamp.py. You see, I'm already. This is not a great year. Something is wrong here. Beautiful. Thank you, Tim. Happy you found it cool. So, all right. So with this, I'm good. I'm going to go grab lunch and I'm going to keep working. I have a lot of stuff to do this afternoon. I have Qt and C++. Woo! Nasir. That is some high-end stuff. I actually want to do C#. I actually want to do C++ a lot. I find it probably one of the most difficult and tedious programming languages for reasons that we will see very soon, but it's also one of the most powerful ones. So I don't discard doing that because with C++ also comes open frameworks, which I'm a huge fan of, and also comes doing OpenGL from scratch or Vulkan, whatever, you know, which is also quite exciting. So we'll see. We'll see about that. Okay. Maybe at some point. What we should review for next section? You don't need to review anything. Don't worry. Everything you need to know, you learn it here. Do you think you could cover modifying the appearance of components? I'm actually really bad at that, Nicholas. It would take me some research, but it's actually quite an interesting proposition. So I'm going to put it on the list, see if I can do a small spike to research how that works. And we can take a look, like gradients, Boolean toggles, etc. Yeah. Maybe we can take a look at that. I just don't know how to do it out of the top of my head. But actually, if you find some examples, send them my way and maybe I can take a look and then I can come up with a video to discuss those topics. All right. Beautiful. With that, I'm out. Thank you very much, everyone. See you hopefully next Friday if everything goes well. Have a nice week. Put your mask on, stay safe, get vaccinated and boosted on whatever, etc., etc. Or whatever you want to do with your life. Up to you. Beautiful. Thank you very much. Bye bye, everyone. Cheers.